Okay, so this is going to be a lesson over surface area of pyramids and cones. And to start it off, we're actually going to discuss the slant height of things a little bit too. So just so you know, there will be kind of a similar theme here. But as we move forward, understand that these are very similar things. It's just pyramids are working with regular polygons and cones are working with circles. So as I said before, the first one we're going to look at is a pyramid, and we're going to talk about the different parts of a pyramid here. You'll notice that this is labeled, and it kind of helps us out. First of all, we have our base along the bottom. This would be a regular square pyramid. It's got a height of h and a slant height of L. Again, the height is straight from the vertex down to the center of the base. The slant height would be from the vertex down the side of the pyramid, connecting to one of those sides of the to one of the sides of that square base. So again, and then those triangles that are all the way around are called lateral faces. Okay, so we have an example here. It says the pyramid at California State University, Long Beach has a height of 192 feet. The base of the pyramid is a square with a side length of 345 feet. What is the slant height of the pyramid to the nearest foot? You have a couple of these in your homework. There is an example here. I felt that I should go ahead and show you this, but look at the red shape on the inside of this pyramid. Really, all we need to do this problem is to remember the Pythagorean theorem. You'll notice that 192 feet is straight from the vertex down to the center of the base. The 172.5 is from the center of the base to that exterior side. And you'll notice that there's a right angle inside there formed by those two legs. So we can just use the Pythagorean theorem to solve this problem. And that's kind of what I have here. So pay attention to what you need and what you want. Looking at this slant height, if we look at the way we want to work this problem, we have 192 squared plus 172.5 squared is equal to that slant height squared. If you want to say c squared, that's fine too, because it is the Pythagorean theorem. You get 66,620.25. You square it both sides, and you get approximately 258.1 feet is the length of that. And again, that does kind of check out to what we want it to be. We know that this side right here should be longer than those two legs that are formed that form that right angle. So that would be an example of what you have in your homework. So here's something kind of similar. Go ahead and take a second to try this. Pause the video if you want. But again, you're just using the Pythagorean theorem. So just use the Pythagorean theorem to try this out. Okay, so here's the work that you need. 21 squared plus 20 squared is equal to c squared. 441 plus 400 gives me 841 if I square root both sides. We get 29 yards for the answer. So on to the next type of problem that we're going to be working today in our homework, and that's the surface area of a regular pyramid. We have the formula here. It says the surface area S of a regular pyramid is a sum of the base area B and 1/2 the product of the base perimeter and the slant height L. We've talked about the perimeter of the base and the base. Those capital variables mean that it's not just a dimension, but it is a collection of information from the shape. So keep that in mind. I still have lots of students trying to give me a side length for the base or um, a side length for the perimeter, and it's not. It's an area and it's a perimeter, so we have to keep that in mind. So here's an example of a problem that you'll see. It says find the surface area of a regular pyramid. Again, this is a square on the base, just like those others that we've seen. So it says find the perimeter of the base. Again, notice that since it's a square, we have to take 10 times 4 because there are 4 sides to that square. Lots of students make the mistake of accidentally adding up 10 twice and forgetting about the other 2 sides that are on the back side of that pyramid. And again, another mistake that is commonly made by students is that they just count this 10 right here as being the base. Again, the base, that capital B, is the area of the base. So we want to take 10 times 10 and get 100 centimeters squared. Then they basically just plug those numbers into the formula. You'll see right here the base is equal to 100. We have 1/2 as part of our formula. Perimeter is 40 and slant height is 13. Once you plug them all in and do all the work, you get 360 square centimeters. So now we have a practice problem for you to go ahead and try again. It really does help to write the formula out first. So go ahead and write that formula out. Surface area is equal to base plus 1/2 perimeter times slant height. Then this square pyramid is going to be very similar to the one we just saw. Go ahead and pause if you need to try it. And then once you're finished, go ahead and click play and we can begin finishing this out. Okay, so we have the formula again. Like I said, it really does help. Then I used the information here. So 1,764 is the area of our base. Our perimeter, 42 times 4 is 168. The slant height of this is 72 millimeters. So then when we plug those all into our formula, we get 7,812 millimeters squared. Now for the last type of problem we have, it's our cones. It's going to be very similar. We just have to remember that cones and pyramids can't be the same because you can't count up all the sides of a circle. We have to use a different formula. Also, you don't have the same formula for area, but if you notice here in our surface area formula, it still says capital B. That still means find the area of your base. We just have to be careful of what we're given and what type of shape we have. So as you go through here, notice that there's two different types. You can have the base plus pi RL, or you can just go straight to pi r squared, which is the area formula for a circle, plus pi RL. Now for an example problem that says find the surface area of a cone, round to the nearest square inch. So we're going to round to the nearest whole number, as you can see down here at the bottom, but you're only given two pieces of information for the cone, so it should not really be that hard to figure out where you're plugging things in at. More often than not, when students make mistakes here, it's on calculation errors. They try to rely too heavily on that calculator, and you want to be careful of that. One thing that the textbook does that I also like to do is it puts things in terms of pi until the very end, and then it multiplies by 3.14. So you'll notice that it took 7 times 24 and then 7 squared, and it added all those numbers up, and the solution came to 217 pi, and then you took 217 times 3.14, and you got 681.7. The book says to round to the nearest square inch, so we put 682 square inches. So again, it's pretty straightforward. You just have to look and see what you're supposed to plug in where, and then start your calculations. Now for our last example here, again, we have a radius, we have a slant height, it's tipped over, it's upside down. It doesn't matter which way the cone or pyramid is shaped or shifted. You just need to plug in the correct information. So go ahead and take a second, pause, and try this one out. Okay, so here's our last thing. Again, we say base plus pi times r times L. Our base was 204.1 centimeters squared. The pi r L part was 376.8 centimeters squared. So surface area with the decimal would be 580.9 centimeters squared. I have some things that I kind of watch for when students rely on their calculators, and when we work with pi, I give leeway. So what I do is I'll take this answer, and if you got something like 580 centimeters squared for your answer, I would accept that. Or I would accept 581 centimeters squared. And it just kind of depends on how students use their calculators, because sometimes they will come up with different answers. But understand that I do allow a little bit of wiggle room for you guys when there's rounding involved and multiplying by decimals and all that kind of thing. Well, that's our lesson for today. Hopefully you learned a lot, and hopefully this will help you out on your homework. Have a good one.